This is about lolpop. Lolpop is an open source project that I created and released last year. It is not related to my day job. It's just something I do for fun in my free time. And so what it is it's a software engineering framework for machine learning workflows. And maybe that makes a lot of sense to you right now, and maybe it doesn't. But hopefully by the end of the talk, it will make some sense. So first part, we're going to talk about motivation, like why would you create this? Why do you get out of bed in the morning? Like why would you create an open source project? I've been working in data and AI for about 15 years, unfortunately, and I've learned several things in that time. One is that small teams really struggle doing anything with ML. And the reason is because, in my opinion, they just lack resources and time and proper motivation from executives to really do hard things. ML is hard. It's always been hard. It's going to continue to be hard until the robots take over. So they're usually under a lot of pressure. This is a great one of Sad Keanu. He's a data scientist, but he's also a ML ops engineer. He's a data analyst, does data engineering. Like you end up doing everything at a small company. Large teams also struggle. Recently I had kind of started thinking like, oh, they must have figured it out by now. And I think the reality is that large companies still haven't really figured it out. I think the best case scenario for large companies is, teams exist in islands, and those islands have maybe figured it out for their product, but broadly, there doesn't seem to be a lot of adoption of like best practices on how you actually execute ML at larger companies. So I like this one of like, my team has my stack, your team has your stack. What sucks is if the ownership of a workload changes from one team to another, because that means we either have to migrate the workflow, which sucks, or we have to learn a new stack, which also sucks. Compromise is never an option. That's why there's not a button there. So small team, large team, you struggle. We've been led to believe this diagram is very important. You've probably seen this at some point. This diagram basically just says that the actual code of your machine learning workflow is not significant in terms of like the overall process. There's a lot of other stuff. And that's true, but I think that we are in like a world where this is no longer really valid. And I think it's no longer very valid is because essentially that was used to justify the creation of new tools. To say like, hey, you need a model repository, you need a feature store, you need all these things, right? Like go buy some more stuff and that will solve all your problems. And the reality is, we've built a lot of really good tools. We have really good tools out there for a lot of stuff. And we actually built too many tools, right? Like our toolkit, if you go out there, and I'm sure you've all seen like every year you get like the mad diagram of the AI landscape and there's 5,000 million companies and tools out there that you can choose from. And if you're at a company trying to build ML workflows, it's really overwhelming. Like where do you start? How do you even figure out what works best for your company? It can be very tough. So I think like focusing on the tools is the wrong way to approach the problem. And my proposal is that instead of focusing on the tools, we should focus on the process. And this is a subtle difference, and in 15 minutes I probably can't really do it justice. But the idea here is that machine learning and data science teams need to come together and decide how are they going to standardize their work. Much the way that software engineering teams do today, right? If you're on a software engineering team, everybody is not doing their own thing. And like software engineering teams at the same company, they all pretty much do things the same way. And when you go and you look at the data science and machine learning teams, that's like never the case. So the analogy I like to use for this is the assembly line, right? So in an assembly line, you and everybody else in the assembly line, you've agreed on the process that you're going to use to like make this car, right? You can make different cars, you can use different tools to make your cars, but we've agreed on the process. We've agreed this is how we're making cars. And I think that is essentially what has been missing from machine learning. So I have lots of evidence. This here is just a quick email I got a couple weeks ago from a friend of a friend who said, I'm at a company and we're doing ML and it's terrible because the only process we have is sharing notebooks on Teams. And that's not a very good process, right? This is one of the better examples I have in terms of like, this process is not the worst that I've seen. I've seen way worse stuff, but this one just happened to be near the top of my inbox. So if you're old enough to have been like a software engineer like in the 90s during the dot-com boom, it had a similar feel then. I think like software engineering kind of figured this out during that era. And we started using things like Git and all that other stuff that now makes like software engineering a lot easier. We started doing unit tests, stuff like that. So this is a book, Steve McConnell, Code Complete. I read this in college a long time ago. But it really spells out like, you should do testing, you should have good design principles, blah, blah, blah. And I think that is something the machine learning industry, machine learning world has kind of missed. And honestly, it's been a hotly debated topic in a lot of ways. So, this is a good one that shows like, people kind of in the middle who are doing this on a day-to-day basis, like, like machine learning and software engineering, they're different. Like, I'm a machine learning engineer, I'm a data scientist, I don't need to do the software engineering stuff. But I think the reality is that it actually is a lot more, or it should be a lot more like software engineering for like true production workflows. So we are making progress. There's a book, Software Engineering for Data Scientists, that Catherine Nelson is writing for O'Reilly. I haven't read it. It's recently been an early release. I know about it because I had proposed the same topic to O'Reilly when they had asked me to write a book, and they said, someone's already going to write that. And I said, I'll just go build an open source framework instead. So lolpop is hopefully going to help with this as well. All right, so Act 2, we can say like, all right, well, maybe you have bought in that we need like to approach ML more like a software engineer. What are the core principles that we should adhere to? So I've boiled this down to 4. First one is modularity. What is modularity? Modularity just means like when you're building things, you should build things that are small and self-contained. And they should have like a common API that things of the same type can leverage. So Lego is like a good analogy for modularity. The next one is composability. Composability means I can take my modular objects that I've built and I can put them together to build different things. So I could build a castle, I could build Bowser. And abstraction is a key one as well. With abstraction, what you're doing is you're able to work on a higher level so that you're not actually concerned with how the modular pieces operate, right? And I think that's key for a lot of data workflows. When you apply that to machine learning, if I'm building a machine learning workflow, like I don't need to know how my model trainer works. I just need to know that I need it to like train on data and give me a model back. So abstraction is pretty key. And the last one is extensibility, and I think this is one that a lot of people miss. Especially as builders, you need to be able to build, right? So if you're in a system and you don't have an escape hatch to build your own thing and to have it apply to your system, to your process, I think you're gonna have problems. All right, so introducing lolpop. Lolpop is an open source framework for machine learning workflows. It's meant to help the data science machine learning community build and run machine learning workflows quickly while following software engineering best practices. So that's kind of key. You'll find other things out there that like, quote unquote, help you run things, but do they help you do it while following software engineering best practices? So how do we apply those 4 key principles I just laid out? Well, how lolpop works essentially is you build out small components. So in this example here, we have 3 different components, but let's take this model trainer. And the model trainer, I might have an API that has a fit function that would take data and return a model, and I might have a predict function that would take data and make predictions on that data. So I could implement this across different libraries, right? I could have a scikit-learn model trainer, I could have an XGBoost model trainer, CatBoost, PyTorch, whatever, but they're all gonna essentially be the same type of object. They'll be a model trainer object. Then I can take those components that I've built and I can start to build up higher level processes with them. So I can take my model trainer, I can put it in a training pipeline. That training pipeline will probably also have other components that I've built, like a metadata tracker or a resource version control system, maybe a model repository, stuff like that. And then this pipeline is also itself going to adhere to the same principles, and it will expose an API. So it'll know how to do things like train a model, run model checks to see if your model is good, evaluate your model on common metrics, stuff like that. And depending on your use case, you can keep going up and building up further layers, further abstractions for people to work at each level. And lolpop has this default this default hierarchy of components, pipelines, and then above pipelines, there's also runners, which are meant to represent your end-to-end workflow, that you just call the one method of the runner, and it runs exactly what you need in production. But you can implement completely arbitrary hierarchy in lolpop if you have decided the default 3-layer hierarchy doesn't meet your needs. I think it meets like 95% of the needs, and that's why it's the default, but you can go and build your own stuff as needed. All right, last one is abstraction. No, third one is abstraction. So abstraction, on the left here is like your pipeline code where you would actually like, as a user, maybe write a pipeline. So in this case, I'm writing a pipeline called my training pipeline. And in this, I have a train model function. And my train model function has a model trainer object. And it's going to call fit on that, and it will give it some data that is going to be passed into the function. And that's really all I need to know as a user about the APIs. Like, that's all I have to know. You will then have configurations that you can apply to your workflow at runtime. So here's an example configuration where I'm going to tell my runner it's going to use that training pipeline that I created, and then my training pipeline will have a model trainer component. And for this run, I want to use a cat boost trainer. So I have some component that's a cat boost trainer that will implement cat boost, and I can give that model trainer configuration, right? And that will tell cat boost trainer how I would like it to work. So what's nice about this is because you're coding at an abstract level, I can use the same code to solve many different problems on different data sets using different components. I never have to change this code. What I change is my configuration over here. Maybe I have different training data to put in, or I want to use a different model trainer, or I want to do hyperparameter tuning and try a bunch of different things. That's all possible. And the last one is extensibility. Lolpop has a bunch of built-in classes. So, if you want to build a new one, we have base components. You just extend our classes and then overwrite what's needed. So the base classes have a lot of the secret sauce that kind of like do all the class binding and make everything work the way it should. And then you can just, if you want to overwrite fit for your particular, maybe I'm doing PyTorch, so I'm not going to call cat boost classifier on PyTorch. I would call the PyTorch API, stuff like that. And there's a lot more. We only had 15 minutes here. There's a ton of pre-built integrations. This is a small selection of them that I've built out. We have built-in testing frameworks. So if you're a software engineer, you're probably saying, like, you didn't talk about testing at all. That's obviously important. And I would say, yes, it's obviously important. I only had 15 minutes. So there's a built-in testing framework, so you can actually test every function of every class you want, and you can do that in the same configuration-based approach. Documentation, I think, is super important, and a lot of companies I've worked at have not done well at documentation, in my opinion. I have implemented something that you can just plug in your own API key to like ChatGPT or whatever, and you can actually have ChatGPT generate documentation on things you're writing, and it's usually pretty good at documentation. So there's a lot of other stuff as well. And I think next we'll just look at a very quick 1-minute demo. Yes. All right.
Look at that fancy title graphic.
So here's our configuration. We're spelling out the pipelines we want to use here. These are going to be global components that every pipeline will have access to, and then common configuration. Then over here will be pipeline-specific and component-specific configuration. On the right here, we'll just use the lolpop CLI to run a workload. We'll run our regression runner, which will has some kind of a workflow for a regression, and I just give it the YAML file that has a configuration. So it's going to do a lot of stuff like use Evidently AI to do your model checks. It's going to do hyperparameter tuning with Optuna. It'll do model visualization via Yellowbrick. It's creating a bunch of objects. Those get stored in MLflow. So it's versioning everything with DVC, stores all your metrics and stuff in MLflow. And all of those they're all swappable, right? So if you don't use MLflow, you use something else. You just swap out the MLflow component with the thing you do use. And that's the quick demo. It just runs. And then you have everything where you want it. So that is it. That's the talk. If you are interested in this, and I will say, like, the point of this talk is not really to get people, or the point of the project is not really to get people to adopt the project. The point is really to get people talking more about implementing software engineering best practices. So I view this as kind of like an example in implementation. I do think it's actually done very well, and small teams could come and adopt it and be successful with it. But if you're at a large company, you're probably too far in the hole with tech choices you've made to like rip everything out and say like, well, let's use this open source thing. But if you're interested in learning more, there's a GitHub, easy install on PyPI. There's a lot of docs. There's a couple blogs that kind of spell out the vision and how we expect people to use this. And we're looking for contributors. If you have examples of really robust end-to-end workflows, I would love to see those and try to get those in as well. That's it.